mag-aral na tayo. Halina, 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 mag-aral na tayo.
Thank you very much, Ma'am Heidi. This time, mga Batang MANDunong, allow me to introduce to you our review teacher for statistics and probability using the CLAID module. She is a teacher of mataas sa paaralan ng MPNAG Gonzales Senior High School Department. She finished her master's degree at St. Jude College, an MTOP trainer. Ladies and gentlemen, Mrs. MARYANN B. UC. Ma'am, it's your turn.
Thank you so much for the excellent introduction. Before we begin, I would like to express my gratitude to everyone who contributed to the success of Project SOAR, headed by OIC STS Dr. Romela M. Cruz, OIC ASTS Dr. Aurelio G. Alfonso, SQOT Chief Mrs. Emma G. Arupio, CID Chief Dr. Aline G. Mendoza, Education Supervisory Mathematics Mr. Restituto R. Rodelas, our Principal in Mataas na Paaralang Neptali Gonzales, Mr. Henry A. Sabido, ASTP Senior High School Mr. Ryan O. Medina, and lastly to our Mathematics Head Teacher Mrs. Liberty A. Noblesa. Special thanks to Nero Lian Rachel and John Cord Sanchez. Let me also acknowledge the writer of today's topic, Mrs. Elizabeth M. Lontayaw, a senior high school teacher from Eris. Senior high school learner, Batang MANDunong. Join me today's session, Quarter 3, Week 1. Our competency for today's topic, illustrate and find possible values of a random variable. Objective: at the end of the learning episode, you are expected to first, illustrate a random variable. Second, find the possible value of a random variables. Don't you know that there are so many situations in our life where the outcome is determined by chance? These outcomes are described mathematically as random variables. In this lesson, we will discuss random variables and how they are present in more situations than we might realize. Before we start on in our topic, let us define first some basic concept, wherein it is very important for us to really know all about the random variables in which we can use it or apply it in our real life, such as in decision making. Every time I look at this picture of rolling a die, I always remember my childhood days in which we are bound and play together as a family. The most important thing that you must know is that before rolling a die, you do not know the result. This is an example of a random experiment. A random experiment is an experiment that can be repeated numerous times under the same condition. Its result must be independent of one another. In particular, a random experiment is a process by which we observe something uncertain. After the experiment, the result of the random experiment is known. When we repeat a random experiment several times, we call each one of them a trial. Thus, a trial is a particular performance of a random experiment. In the example of tossing a coin, each trial will result in either head or tails. Always remember that the sample space is defined based on how you define your random experiment. The first example of random experiment is the tossing of a coin. When you say coin flipping or coin tossing, it means it is the practice of throwing a coin in the air and checking which side is showing when it lands. In order to choose between two alternatives, head or tail, sometimes used to resolve a dispute between two parties. It is a form of sortition which inherently has two possible outcomes. The party who calls the side that the coin lands on win. During a coin toss, the coin is thrown into the air such that it rotates edge over edge several times, either beforehand or when the coin is in the air. An interested party calls head or tail, indicating which side of the coin that party is choosing. The other party assigns the opposite side. Depending on custom, the coin may be caught and inverted, or allowed to land on the ground. When the coin comes to rest, the toss is complete, and the party who called correctly or was assigned the upper side is declared the winner. Another example of random experiment is rolling a die. When you say die, singular for die, are small throwable object with marked side that can rest in multiple positions. They are used for generating random numbers, commonly part of tabletop games, including dice games, board games, role-playing games, and games of chance. Dice are thrown onto a surface either from the hand or from a container designed for this. The face of the die that is uppermost when it comes to rest provides the value of the thrown. In a rolling of a die, always remember that the experiment can yield 6 possible outcomes. Another example of a random experiment is the selection of a number 1 to 50 in an urn. The said experiment can yield 50 possible outcomes. In choosing a card from a deck of cards is also a good example of random experiment. In a pack of deck of 52 playing cards, they are divided into 4 suits of 13 cards. Example, spade, hearts, diamond, clubs. Always remember that the card of spade and clubs are black cards, while the cards of heart and diamond are red cards. A sample space, usually denoted by S, of a real or conceptual experiment may be defined as the set of possible outcomes called elements of that experiment. Each probable outcome corresponds to exactly one element of the set. To illustrate, take for example the experiment of rolling a balanced die. There are 6 possible outcomes that will make up the sample space. Each of these correspond to one of the elements of the set 1, 2, 3, 4, 5, and 6. These 6 outcomes are equally likely to occur, which means that each outcome has an equal chance of appearing. Therefore, the sample space S is equal to 1, 2, 3, 4, 5, 6, where 1, 2, 3, 4, 5, 6 are the elements, and each of these elements is a sample space. A sample space may be finite or infinite. A finite sample space as a number of elements that can be counted, while an infinite sample space as an unlimited number of elements. Since you already know the important terms, you are now ready to learn a new topic. Many quantities or variables in different situations are determined by chance. Examples of these are the prices in the market, variables that assume values as determined by chance, are called random variable. It is a function that associates a numerical value to every outcome of a random experiment, which is denoted by a capital letter X. Random variables are central to the use of probability in practice. They help model random phenomena, that is, random variables are relevant to a wide range of human activities, including agriculture, biology, ecology, economics, medicine, meteorology, sciences, and engineering. Let's take an example. Let X be a random variable that denotes the result of a rolling a die. What are the possible values of X? In this problem, we should apply some step on how to determine the random variables on any events or experiment. Like, we should first determine the sample space. Second, assign letter that will represent each outcome. And lastly, we could count the number of the value of the random variables. In this problem, the sample space of a rolling a die is S is equal to 1, 2, 3, 4, 5, and 6. Therefore, we can conclude that the possible values of X are 1, 2, 3, 4, 5, and 6. In problem number 2, a coin is flipped 3 times. If X represents the number of heads of the outcomes, what are the possible values of X? From the given table, the possible outcomes are head, 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 tail, head, tail, head, head, tail, 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 head, head, tail, head, tail, 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 head, tail, tail, tail. The next thing that we must do is to count the number of head. In head, 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 there are 3, head, head, tail, 2, head, tail, head, 2, head, tail, tail, 1, tail, head, head, 2, tail, head, tail, 1, tail, tail, head, 1, tail, 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 0. Based on the table, the number of head can be 0, 1, 2, and 3. Therefore, we can say that the possible value of X are 0, 1, 2, and 3. In a problem number 3, let M be the number of males in a class with 30 students. What are the possible values of M? The number of males in a class could range from 0, all the students in the class are female, to 30, all the students in the class are male. Therefore, we could say that the possible values of M are 0, 1, 2, 3, 4, up to 29, 30. In problem number 4, a mother will give birth to a twin. If X denotes the number of boys, what are the possible values of X? In this problem, the first thing that you must do is to list the possible outcome. Let V represent boys and G represent girls. By just looking in the picture, we can say that the possible values of X are girls, girl, boy, girl, boy, boy. We know the fact that the sex of baby can only be determined by chance. We can associate numbers to each sex. 1 can be boy and 0 can be girl. In this situation, the sample space contains outcomes of 0, 1, and 2. Another way of presenting is through the use of table. From the given table, the possible outcomes are girl, girl, boy, boy. The next step that we must do is to count the number of boys. Based on the table, the number of boys are 0, 1, and 2. Therefore, we can say that the possible value of x are 0, 1, and 2. Suppose there are P people to be tested in COVID-19. Let P represent positive, N represent negative, and Z be the random variable representing the number of infected persons that occur. Find the random variable Z. From the given table, the possible outcomes are positive, 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 negative, positive, negative, positive, negative, positive, positive, negative, negative, positive, negative, positive, negative, positive, negative, 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 negative. This time, we have to count the number of positive. In positive, 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 there are 3. Positive, positive, negative, 2. Positive, negative, positive, 2. Negative, positive, positive, 2. Negative, negative, positive, 1. Negative, positive, negative, 1. Positive, negative, negative, 1. And negative, 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 0. And based on the given table, we can say that the possible value of Z are 0, 1, 2, and 3. Our last problem for today, 2 winners will be drawn from 5 security guards and 6 canteen staff. Let W be the random variable representing the canteen staff. Find the values of random variable W. We let S be our security guards, and we let C our canteen staff. Based on the given tables, our possible outcomes are canteen staff, canteen staff, canteen staff, security guard, security guard, canteen staff, security guard, security guard. After we count the number of canteen staff, we can conclude that the possible value of W are 0, 1, and 2. Thank you so much, Senior High School learner Batang MANDunong, for listening to my lecture. I hope you learned from me. From the bottom of my heart, thank you and God bless you all.